Hello everyone and welcome to today's webinar entitled Sifting and Winnowing, Analysis of Farmer Field Data to Identify Yield Gaps in Soybean across the U.S. North Central region. I'm Chris Boomsma, Director of Education here at the American Society of Agronomy, and it's my privilege to be the moderator for today's webinar. And so with that, let's get started. First of all, I want to thank our sponsor. Today's sponsor is the United Soybean Board. With their generous sponsorship of this webinar, it comes to you free of charge. And so we are certainly thankful for them and all they do to support continuing education here at the American Society of Agronomy. A few housekeeping items before we get started. First of all, if you are having any issues, whether it be with the course content you see in front of you, maybe you're not seeing the slides properly, maybe you had an issue with registration or something technical, please contact Michelle Lovejoy. You can reach her at the email address on your screen or the phone number that's listed right by that. Secondly, please type your questions in the questions box and submit them to me at any time. We will have a nice question and answer period at the end of today's webinar, but we're going to hold all those questions until the end, at which time I'll have accumulated all of them, put them in order, basically by the time they come in, or in accordance with the time that they're submitted, and then pose them to today's presenter. Okay, so submit them anytime. You do not have to wait. Third, please note that this training session is being recorded. It'll be available to all participants about 1 week after completion of this presentation, hopefully sooner, and you can refer back to this presentation if you like in the recording. Next, please note that this webinar is part 2 of a 3-part webinar series on using precision ag technologies to improve on-farm economic and environmental sustainability. So this 3-part series is all sponsored by United Soybean Board. We're into part 2. If you missed part 1, go back and take a look. It's in our library. It was on planting technologies. And now we're moving into today's topic. We will follow up with a timely topic later this year on harvest and post-harvest technologies and how it connects with sustainability. But more details to come on that at a later date. Also, please be on the lookout for future webinars that will be offered by the American Society of Agronomy in the coming months. We're going to start ramping up webinars in later July, going through September, maybe a little bit into October, taking a break during the fall, during harvest season, and then ramping back up again as we get into the heavy education season. So be on the lookout for those. They're coming your way. Now, let's get going towards the presentation. First, I want to introduce today's speaker, who is Dr. Shawn Connelly, who's a professor of agronomy and state soybean and small grain specialist at University of Wisconsin-Madison. His research goal is to generate science-based solutions to address real-world problems in soybean and small grains. He then takes this knowledge that he generates through research, integrates it, and delivers it through his extension program. As you can see on your screen, he's a prolific author and presenter. Over 100 referee journal articles, spoken at greater than 710 events to many, many clients since the beginning of his academic career. He's committed to agriculture, the Wisconsin idea, and was the co-author of a great children's book entitled Cool Bean, the Soybean. So check that out if you haven't seen it before. Lastly, if you want to follow him, please look at coolbean.info or follow him on Twitter at BadgerBean. There you can find some nice in-season updates. I'll talk about the USB Tech Toolshed, so hang tight after Dr. Connelly's presentation. But with that, I am going to hand it over to Dr. Connelly. Shawn, thank you for being here today. We appreciate your time, and we look forward to your presentation. Take it away when you get the chance.
Excellent. Thank you, Chris. Well, good morning, everyone. Again, my name is Shawn Connelly. I'm a state soybean small grain specialist at the University of Wisconsin-Madison. Before I get started today, I'd like to first of all thank our sponsor, the United Soybean Board, for giving me the opportunity to speak about some of the checkoff-funded research that we've been doing, not just in the state of Wisconsin, but across the entire North Central region. Next, I'd like to thank the North Central Soybean Research Program for funding the research that we're going to be discussing today. We'll talk a little bit more of the depth and breadth of that as we go along. And I'd also like to thank both the Nebraska Soybean Board as well as Wisconsin Soybean Marketing Board for providing additional funds to move this project along, because it's going to be, as you will soon see, it's a massive amount of data and a lot of work. And I always tease some of my colleagues, this is a postdoc's dream, as we'll be writing papers from this data set probably for the next 5 to 8 years. So hopefully you'll be able to get a good idea of what we're discussing as we go through. Last but not least, I'd like to thank all the co-authors on here. We'll talk about them a little bit more as we get into the slides. But without them, we would not have been able to collect the massive amount of data that we've seen. So as we get into today, as a reminder, the title of this talk is Sifting and Winnowing, Analysis of Farmer Field Data to Identify Yield Gaps in Soybean Across the U.S. North Central Region. And roughly 90% of the data that I'm going to be presenting today has already been published in scientific journals, as well as posted on my website. So if you are looking for additional resources and materials outside of this webinar to kind of dig a little deeper, please go to my website, which is again www.coolbean.info, or follow me on Twitter at BadgerBean as we post information on a daily basis about what we're seeing in the field. So with that, let's kind of get started and kind of dig into the data set. So the main goal of this research project itself is to benchmark current yield and management practices in producer fields. And this would be across the entire North Central region. And one of the things we're looking to do is to identify those key management factors that can help farmers or producers increase not just yield, but input use efficiency and drive sustainability along their entire continuum, which is both environmental, economic, and social sustainability, which are the three tiers of sustainability that we discuss with. Now, just to kind of get a better idea of the scope of this project, the area we're focusing in on, or the North Central region, is roughly 30% of global soybean production, or roughly 80 to 82% of the U.S. soybean production. So it's quite a large landmass area as well as productivity zone. So the scope here is really kind of dig deep into what farmers are doing on their farm and be able to identify and sort out which one of those practices best drive economic, environmental sustainability. And the thing we're focusing on here is this yield gap. For those of you that are unfamiliar with what a yield gap is that you have the genetic yield potential that is in that bag of seed. And I would argue for most of the North Central region, the genetic yield potential on soybean is roughly 120 bushels per acre. All right. However, once you plant that seed into the ground, we have different climate, soils that give us more of a potential yield that's off the genetic yield potential. Okay. From that potential yield, then we have the actual realized yield, which farmers capture on their farm. For example, last year the state average yield in Wisconsin was 47 bushels per acre. So if we know the genetic yield potential is 120, the potential yield is, say, 100, and we only average 52. That means that 48 bushels is what we characterize as that yield gap. And what we're trying to do is dig into what farmers are doing behind the farm gate to minimize that yield gap. So one of the ways we've traditionally done this type of work is through these agronomic field research, replicated plots. Anyone that's gone through, gotten their master's, gone through a field tour in industry, we use very similar tools. One of the challenges with these tools is we're limited mainly on the scope and scale and price, or the cost, to be able to look at all of the factors that we're interested in. Because as we know, when you put seed into a biological system, there's many factors and interactions that are going. And sometimes it can be a challenge to look at all of those factors in a replicated study on a small number of fields and then blow that up to look at broader implications if those production practices are implemented. So what we're really trying to do is add another level of scale into our production research and how we do trials. Now, I'm not saying the way we've been doing them in the past are not the way to do it, because we've made a lot of progress, genetics, management, over the last 100+ years we've used these techniques. What we're trying to do then is look at a larger scale, find those interactions that may come into play, and then bring that back to some of these smaller field scale trials that we can really test and tease out those interactions. So what we're doing here is just looking at it, research from a different scale. So one of the questions we had is, with farmers collecting as much data as they are today, is this a path forward for us to be able to utilize farmer reported data and utilize that information to parse out the hundreds of different management practices and inputs that our farmers are doing, and develop some kind of a hierarchy of which ones, in a sense, give farmers the biggest bang for their buck, and on what scale that comes across at. So our hypothesis for this experiment was, can we use producer data to efficiently identify these suites of management practices that consistently lead to higher yield and or input use efficiencies in a given climate soil domain. Okay, so that's kind of the scale that we're looking at using farmer data. And what's really driving this is this whole idea of big data. Today we have the capacity to not just collect all of this data, but also we have the supercomputing capacity to actually dig into this data and parse out what these interactions are. And we hear about this a lot in the media, in the ag world, even outside of the ag world. Big data, big data, big data. The question is, how can we efficiently parse that out and develop a methodology that farmers or any of us in the scientific community can parse through that big data and make heads or tails from that? Because again, remember, every single farmer is doing something a little bit different on all their acres. And basically what we wanted to do is develop a methodology to capture and utilize this data on a larger scale. So now I'd like to dig into the core team here, and again, give some thanks to these core teams. So the co-PI on this project with me was, or I should almost say the lead PI was Patricio Grassini at the University of Nebraska. And the core teams were Nebraska and Wisconsin. And without our postdocs, Juan Rotellino, Adam Roth, and Spiros Martiznes, this work would not have got done. So I really want to thank them. But I also want to thank all of our regional collaborators or state collaborators that collected data from us in all of these states that are shown here. And without them, we wouldn't be able to amass the huge amount of data and bring that information into the system and be able to look at how these management practices are reflective across these different environments. So how we have collected this data is we worked together as a big team and we developed the survey data template. And this template was given out at producer meetings. It was on my website, email. We would mail them out. You know, each state did a little bit of different methodology for how they collected the data. But if we look here, what we really see on this is the data that we collected. And this went anywhere from what was a planting date, what was your soybean yield and the yield variability across your farm acres, what variety names, seeding rate, row spacing, basically all of the different production practices and management practices that farmers utilized on their farm. The biggest stickler point that we usually ran into at first was the GPS locations, and those were vital for us because we were able to then go in, and I'll show you in the next slide, basically go into Google Maps and map out the entire borders of their farm field, and then pull in all the soils data from the Surgo Soils database, and then all of the environmental data from there. So again, not only did we have management practices all detailed out, but we had all of the weather and all of the soils information that we could layer that in and develop this database from which we were able to start looking at those management practices that drove yields across the United States, specifically the North Central region. So after 3 years of experiments, collecting data from 4 years actually, and cleaning the data, we came up with roughly a little over 8,000 fields. So our N was 8,015 fields, which captured over 600,000 acres of data. So again, in terms of big data in our database, we had a tremendous amount of information we could parse out. And if you look here, each one of those red dots identifies one of the farmers, not specifically identifies them because they were left nameless and we didn't identify them. But again, a regional idea of where and the information came from. So the biggest question then is, once you get all of this information, how do you make these fair comparisons? Because again, farm fields differ. How do you compare this example, a rain-fed field in central Nebraska with an annual rainfall of 610 millimeters versus a farm field in central Iowa where at 890 millimeters? Okay, how do we basically parse these fields up and make these fair comparisons? And we did that using a spatial framework called a TED, or a Technology Extrapolation Domain. What this is a spatial unit with a unique combination of biophysical, which is both weather and soil attributes, in which responses to a given technology can be expected to be fairly similar. And in layman's terms, what does that mean? We basically found farm fields or environments across state borders that would perform similarly in terms of what the rainfall pattern was, their soil water holding capacity was, and their productivity and GDUs. All right, we're able to parse these fields together and look at and pool those farms in these similar TEDs to be able to make comparisons then within a given TED of the different management practices that farmers were doing across these TEDs and within a TED. Just for an example, this is a figure here with all of the crop reporting districts with average yield in each one of those crop reporting districts, just to give the audience a sense of what the yield potential was across the state and across the region. One of the typical questions we get is how reflective of this is this data from what what the mass majority of farmers are looking at. So what we were able to do then is initially, after 2 years of the work, go through and basically map this out and compare our on-farm yield data with the county NASS average yield. And if we look here on this figure, we see the USDA NASS yield on the x-axis and our database yield on the y-axis. Forget the units, I know it's in metric, but the point here is we look right along the one-to-one line, and our slope is to the left of the one-to-one line, which basically shows that we have similar yields. So we have comparable farmers within each of the crop reporting districts and at the county level to what's occurring at the county level, at least according to NASS yield data. And we're to the left, which basically suggests that we're actually having some of the better or more productive farmers engaged with this process. So again, that this gives us more power and strength to know that yes, we're working with what we quote unquote say the better farmers, but they have a direct relationship to what is going on at the county level. So they're not an outlier, if you will. Now, we'll be showing a few of these slides as we go through, and again, this information is all on my website at coolbean.info. Feel free to download it and spend more time, but one of the biggest drivers that really popped out to us across this work is what a huge driver planting date had on the soybean side of things. Again, we can look here. So this would be the average planting date in a crop reporting district for all the farmers. For example, in Southwest Wisconsin, the average planting date for those farmers that responded to our survey and gave us information was they started planting soybeans on in the second weekend of May. Okay, we had obviously some that were earlier, some were later, but if we're just kind of looking at averages, that's what we're sitting at. Now, as we dig into some of the TED, and this is the power again of being able to sort out this data and across state lines, we can look at within a specific TED what that response to planting date is. And I will use TED 1R, for example, here. That would be box A in the upper left-hand corner. And TED 1R we see is this darker green coloration. It goes across parts of Ohio, it's in Wisconsin, parts of Northeast Indiana, and the western side of Michigan. So again, we're able to look at the data over a large scope, and we found that starting on April 25th here, this is the days after April 1st, we start losing roughly 0.5 bushels per acre per day by delaying planting past April 25th. So by delaying 10 days, which would be, let's say, May 5th in a normal year, roughly, we would have already lost 10 bushels per acre. So again, it gives us an idea based on the different climates as defined by these TEDs, what the yield response is or penalty for delayed planting is. We can kind of go through here. Let's pick on 4R. In that sense, we're at 0.4 bushels per acre per day. So again, it gives us a sense that. One of the interesting things to note is we see a lot of variability across the country about what this delayed planting may or may not do in terms of yield loss. And what we've kind of found interesting is if you go up to TED 3R, which covers or encompasses North Dakota, we roughly see no response to planting date. Okay, and to me and the rest of us on the core team, we found this kind of interesting. So what we were able to do then is kind of dig deeper into why we're seeing this variability of responses from anywhere from no response to up to 0.5 bushels per acre per day. And what we're able to discern with that is it came down to water balance during pod setting. And I think that's something that's intuitive for most of us, but based on the climate and soils and the specific TEDs, we don't, and the rainfall patterns, seasonal rainfall patterns in these areas, we see that once we get basically less than a -1 inch water balance during pod setting, which would roughly be R3 through R7 into R8, where we have that seed fill period, that's where we see the biggest response in this lack of a response, I should say, to delayed planting. So in a sense, when we see 1R, we don't really see in that TED, at least over the scope of this experiment, we did not see any issues with those soybean fields being short of water. So again, there's a bigger response. So again, it helps us to kind of explain why we see these variations. And again, it gives farmers in those zones an idea of what that response would be to planting it. Specifically in North Dakota, they don't have to rush out there if they want to. It's pretty stable and flat what that response is. I mean, it's basically no response to planting date. However, if we get into, again, TED 1R, one of the ways farmers are utilizing this data is, can they basically cost effectively go out and purchase another planter, pay someone to go out there and physically start planting soybeans, and what would be the return on the investment, or how long would it take them to pay off a new planter, a second planter, to go out and start planting soybeans on April 25th. So it's a very quick and dirty way to help farmers kind of parse some of that information out. Another key and interesting topic we get into is the amount of no-till adoption acres. And again, we see that differs across the north central region. But again, we start looking at some of the issues, not really issues, but these management practices associated with both planting early and no-till, and that brings up specific management decisions or practices that we can focus in on in those areas. Here's kind of an interesting way to also look at this data. So give me a second, I'll explain how we go in and read this slide. So we'll look at basically tile A in the left-hand side of the figure here. And if we look here, we're looking at the difference between tilled ground and no-till ground, all right, within a specific TED. And if we look at the black line, that's a 1-to-1 relationship. And if you look at some of these TEDs, like 6R, 5R, 7R, 1R, that you don't see a star in, that basically tells us that as a farmer, in any of those TEDs, 1R, 7R, 5R, 6R, it really doesn't matter if you go till or no-till in terms of the yield response. Obviously, there's environmental benefits and there's other benefits to tillage or no-till, specific depending on where you are. But it really tells us in those TEDs, it doesn't matter for a farmer. You can go either one. Or if we look at some of these other TEDs, specifically TED 3R, 4R, 2R, and some of these 7I and 9I, which are these irrigated sites down in Nebraska and Kansas, we see a yield response to tillage. Okay, so again, we're not taking into account the added fuel cost, some of the sustainability questions related around tillage and the landscape and profile. What does tell us is in some of these situations there is a yield advantage to till. However, again, we're not suggesting that farmers in those TEDs specifically go in and till all their acres. I mean, there's cost efficiencies involved with no-till and environmental benefits as well. But again, it just gives farmers in those TEDs kind of an idea of where they stand and what the cost net benefit ratio is. Another big question that we tend to get is seeding rate. And what we've seen over time is that seeding rates have precipitously dropped since I started in this job. I started at Purdue University as the soybean agronomist in 2004. At that time, most farmers were planting in excess of 180,000 seeds per acre. Today, however, my recommendation on most soils in the state of Wisconsin is only 140,000 seeds per acre. And if we look here, I would, across the state, not just in Wisconsin, but across the north central region, we see some variation in seeding rate and what drives that. And one of the interesting things, I'm not going to show any slides about this, is we did an experiment probably 5 years ago now, looking at the genetic yield gain. So we had germplasm from roughly 1924 all the way up to 2014. And two interesting things popped. Today's modern genetics respond more beneficially, i.e. there's a synergism with planting today's modern genetics earlier. We get a bigger yield gain, if you will. The slope is greater. Secondly, there's less of a yield penalty today for reducing your seeding rate. What I mean by that is today's modern varieties can put on 3 times the amount of seeds or pods per plant than the genetics 30 years ago. So again, we've effectively moved us into the advantage of reduced, I shouldn't say the advantage, we don't have as big of a down risk side for a lower seeding rate or thin stands as we did 30 years ago because of the soybeans capacity to branch, fill that in and minimize what that yield penalty would be. So again, there's some cool things going on with both the environmental and genetic components interacting to really help us minimize or reduce our seeding rates. And that's obviously important for farmers, specifically as those seed costs continue to rise. So one of the ways we're able to supplement the farmer data is actually go back and dig into some of our small plot replicated data. So here's a little bit of information looking at soybean yield across the north central region. So this is an aggregated roughly 21,000 plots, 211 replicated field trials in both 12 states and basically Ontario, Canada as well. As you see here, what we've done is physically aggregated them into these clusters. Okay, so it's a little different type of an idea than using TEDs. It's actually a paper we're working on right now is trying to compare the efficiencies of TEDs versus clusters. But again, it's just another way of grouping fields together and trying to parameterize, what the responses would be in these different environmental zones. A couple of things kicked out pretty interestingly. First of all, seeding rate really did not have any significant response to seed yield, and I think we've kind of shown that with what's going on with today's modern genetics and that synergy that's going on. But it tends to be seeds per unit area, okay, which is highly correlated seed yield, and seed mass. Those are the biggest drivers in terms of yield. So in terms of input decisions, that's what we're looking at to maximize our soybean yield, is characterizing seeds per unit area as well as seed mass. One of the interesting things to note, however, if we parse these by yield environment, we see no response to stand, either late season stand or early season stand in high yield environments, which is kind of counterintuitive, what you would expect. But frankly, those plants, even in a lower population, are able to compensate so greatly in these high yield environments that we really don't have to really think about. And frankly, for Wisconsin farmers, I push farmers that are in these highly yield environments because they're more susceptible to white mold to drop their seeding rates down to 125,000 or 120,000 seeds per acre, because we don't see an effect on yield and we minimize white mold. So there's interesting things that are kind of interplaying across these disease management and agronomic management disciplines. The other interesting thing to note, and I think it's kind of a key point to bring out here, it's actually in these lower yield environments, we see the response, greater slope to higher stands, okay, or more seeds being out there. And that's kind of counterintuitive because on the corn side, we tend to push farmers to decrease their seeding rates in these lower yield environments, where our data would suggest that in these lower yield environments, we actually want to have more soybean plants out there. So in terms of during a precision ag type of a management, that's what we should be kind of focusing on, is decreasing our seeding rates in high yield environments and putting those seeds in these lower yielding environments to increase yield and give us some ways to minimize evaporation, and also weed control is another big issue in these low yield environments. If we look here at the agronomically optimal seeding rates by these different clusters, we kind of parse those out. As we see here, cluster 1 low yield environment, we are showing an agronomic optimal seeding rate still at 237,000 seeds. Of course, when we add the economics to that, that kind of drops down to roughly in that 180,000, 170,000 seeds. So again, we're still working on this. This is the one piece of the puzzle, if you will, that hasn't been published yet. However, we're working on getting this through the review process right now, just as a note to the group here in case you're looking to find this information on my website. This is the one piece you won't find yet. If we look at the agronomic optimal seeding rate, it's roughly sitting right at that 140,000 seeds per acre, depending on in a high yield environment, regardless of cluster. So we're kind of right there, right around that bag per unit area is what we're pushing farmers to plant, and then pull those down if you have other weed or excuse me, if you have just like white mold disease situations. Just so I want to briefly bring up an app that we developed here. This app is called BeanCam. It's free to download on either your Apple or your Google Play platforms. This was developed and paid for through the Wisconsin Soybean Marketing Board. It's a very simple app that allows you to basically do stand counts. So we quickly figure out what row spacing you're in. This is 15-inch row spacing. These are our V1 soybeans. You line the lines up on your camera and you simply walk around and snap photos. This is what you see on your camera, and this is what your app sees. Here's one of my former graduate students. She's now a postdoc up at the University of Minnesota, kind of testing it in the field. You simply walk through, you take 5 random pictures in the area of concern. It gives you an estimated population. In this case, it's 80,000 plants per acre, and it gives you a % maximum yield. In this case, again, with soybeans, even at 80,000 plants per acre, your maximum yield is 97%. I would suggest in this case you don't do anything. However, the app does give you a replant app to basically go in and fill in. This existing population was roughly 60,000 seeds, and if we see by adding 60,000 seeds, all we gain is roughly 1% yield. So again, that space data tells us it's really not worth your effort to go in and replant. And frankly, my rule of thumb is you don't touch a stand until it's under 50,000 plants per acre. That's kind of a quick and dirty rule of thumb that we've kind of worked on and shown in our data. Okay. After seeding rate, the next big question we always get is row spacing. So here is broken down by the different crop reporting districts, what farmers are doing in terms of row spacing. And if we again, we'll go into northeast Iowa, for example, and it looks like it's pretty much half the 50-50 between 15-inch row spacings and 30-inch row spacings. And again, this data here just compares to NASS, showing that our data lines up with NASS so that we aren't skewed in terms of the growers what we've represented in this survey data. One of the interesting things is we go in and utilize the survey data or the farmer data from our benchmarking project is we see that at a lower yield potential, we still see the yield advantage to that narrow row. However, as we start pushing higher yields, specifically in these irrigated environments, we really see the yield difference between narrow row and wide row disappear. So what this tells us is in these high yield environments, the row spacing debate is a little less mute. Okay, again, we still see it in these low yielding environments, but when we get the high yielding situations, we don't see that response between narrow and wide as great as we did do in the lower yield potentials. So what we were able to do then is kind of pair this up with all the experimental data that my colleagues and I look at across the state. So this kind of shows all of the experimental data, small plot work across the Dakotas, the entire Midwest and the North Central region. And we're able to then kind of compare what we saw between the farmer survey data and what we are experimentally calculating or weighing or measuring, this is the correct term, in our experimental plots. Here is just some of the experimental data, kind of gives us a sense of average seeding rates. Again, not super important, but it goes into the meta-analysis, if you will. And what we found is we break it from north to south. In the north, which again would be Michigan, Wisconsin, Minnesota, North Dakota, South Dakota, we still see roughly in our experimental small plot work a positive 3.6 bushel yield advantage in the north from narrow row versus wide row. If we get across central, which is the ice states, we still see a yield response, but it's a little bit smaller. We're at that 1.6 bushels per acre between narrow versus wide row. In the south, we see a much greater yield advantage for narrow versus wide row, and this is specifically a lot of the data that we came in here was double crop, late planted situations where the planting window is a little bit wider in the south. And again, some of the stress in the environments would tend to really still push farmers in the south to plant on that narrow row spacing. The interesting keynote here is on the ice states in the central region. We know that we still may see this 1.6 bushel yield advantage. However, say you were able to take a sprayer through a field, and in a narrow row situation, and by narrow rows I mean anything 22 inches or less, we see wheel track damage, depending on wheels, how wide those wheels are. So the point I make here is at 120-foot boom, you're still getting roughly 1% yield loss running a sprayer across that field after R1. 1% off of, say, 70 or 80 bushel beans, that gets us at 0.8 bushels per acre, and effectively that makes this whole row spacing debate mute again in the ice states if we're getting in early. So again, kind of helps us show the differences in how our small plot data correlates and with our on-farm data, and how we can use these two pieces of information together to kind of parse out what's physically or biologically going on. And we did this a little bit, and again, here's some more information on the experimental data, but we did this by really looking at a couple key points. What we find is the crop cycle length, so how many days it takes to get from roughly VE soybeans, or when they emerge, to R3 soybeans, which is that first pod in the upper 4 nodes. If we could push that date, regardless of where we are in the north or the south, again, we didn't see much of a response in the central part of the country, we see roughly, if we could stretch that out to around 65 to 70 days, okay, from VE to R3, the yield response to row spacing disappears. So how do we do that? We plant early and we plant later material group bean. We make that period between VE and R3, extend that out, and that row spacing differences disappears. So again, just a biological way of explaining some of this data we have here. The question always comes in with seed treatments. Again, this is from the survey or farmer reported data, what percentage based on crop reporting district. And we see for much of the country, we're 60% plus, and this is kind of an amazing adoption if you think about it. Roughly 10 to 15 years ago, this, at least on the soybean side, would have been 8%. And now we're roughly 80 to 100%. So again, we've seen a lot of changes management-wise, cost of seed, earlier planting fewer seeds, really, push that technology of using seed treatments into what farmers are really doing for most of the, the north central production region. This is just a quick risk table. I'm not going to spend a lot of time on this as I've got a few more slides to get through, but this is on my website. And if we walk through here, it basically shows us, let me go back. Sorry about that. Basically, it shows us what the economic risk table is at $8 beans, which is where we're sitting at now. When you're comparing, say, an ILEVO treated seed at 140,000 seeds per acre versus an untreated seed at 140,000 seeds per acre, there's an 87% of probably return on investment in that case. And on average, that farmer is going to gain $7 an acre. So again, I'm not going to spend a lot of time on these economic risk tables for many fungicide and insecticide packages that are on my website. Feel free to dig into that, and I could spend a whole webinar going through these. So again, just a point to note, and feel free to follow up with me with any further questions. The next point I want to talk about is looking at some of the foliar fungicide and or insecticides. And again, we look across and we see a lot of variation from 0 to 20% of some fields getting sprayed to as much as 80 to 100%, just depending on the crop reporting district. If we dig into this, and hopefully you can remember how to read this slide, but I'll kind of go through it again. We're looking at tile B here. This is the difference between those farmers within a given TED not spraying a foliar fungicide and or insecticide versus those that did, okay? Here is that one-to-one relationship. So if we look in TED 6R, 2R, and 1R, we did not see really any yield difference between farmers applying, and in this case, it's most likely a prophylactic application of this in those areas. However, in many of these TEDs, we did see a significant response. Actually, we're right now through additional funding through the North Central Soybean Research Program. We're working with Dr. Paul Easker at Penn State University. He's an epidemiologist, and we're working at trying to overlay all of these fungicide responses that we've seen across the Midwest with reported yield loss and disease data from the individual state plant pathologists. So again, we're digging deeper into this because again, we don't want to be promoting, just the prophylactic application of a foliar fungicide and or insecticide at R3. We want to do a little better job of explaining and predicting where those responses are. But this is just available for you to kind of get an idea of what we're seeing across the Midwest. Quick point here is on nematodes. I just want to remind everyone that of the SCN Coalition. Again, this has been a huge industry, academia, QSSB, North Central Soybean Research Board, USB program going out to look at this issue again. So again, strongly encourage everyone that you haven't sampled, go out and really figure out what's your number. Take that test and beat the pest and get a better idea of what we're doing or what's going on out in the environment for SCN. Okay, in the last roughly 10 to 15 minutes here, I'm going to kind of go through each state and based on TEDs and kind of show how we are able to look at these suite of agronomic decisions and the synergies that we found in each given TED, okay? And how you would read this is we're looking at statistically, if a farmer's did specific practices in a given TED, what drove the differences between the low yield fields and the high yield fields. Remember, we're using a paired t-test here, and we are statistically looking at this at the 0.10 level to really look at, based on which variables farmers are adopting, how does that influence and drive yield, okay? So we'll start with Wisconsin. In Wisconsin, we have all of these, I believe I've got 9 TEDs here identified. Those dots that don't have a coloration behind them, we just didn't have a high enough N to identify the response in those specific TEDs. So our threshold was we needed roughly a minimum of 90 farm fields that would fall within a TED to give us the statistical power to sort out these management practices. So again, some of these states, we have some dots here that don't fall within a TED. We just haven't collected a high enough N yet to differentiate the management practices in those. So let's pick on here, we'll go number 2, dryland within our TED in Wisconsin. We'll walk through that one. And here's how you read this report, okay? Each one of these is a given TED. So this would be 1D, 2D. This is the average yield in the high yield fields in TED 2D versus the average yield in low yielding fields. And roughly for most of these TEDs, we're right at that 20 to 25 bushel yield separation, okay? If we go down in TED 2D, we see the average planting date in the high yielding fields with May 17th. In the lowest yielding fields, we saw they were May 23rd. We see here that in TED 2D, we have row spacing colored. This basically tells us that there was a response to row spacing In Wisconsin, some of those are positive to wide row, some of those are negative to wide row. And a lot of that is driven by yield environment and white mold. So it's kind of hard to put all of that in one table. People have additional questions, feel free to contact us. We can pull that out. In terms of management practices, and again, the high yield, 77% of those fields had some type of artificial drainage, where 62% had that in the low yield. And finally, 47% of the fields were in the high yield environment were treated with a foliar fungicide and or insecticide, whereas only in the low yield environment, only 11% were. So again, that's a lot to take in. This, all of these figures and maps by state are on my webpage. Feel free to go on, download that, and dig into it. There's a lot more detail in the written information than I could provide here in this PowerPoint. And again, I could probably spend an hour just going through each state and talking about the different management practices within a given TED. Here's the Nebraska environment. Again, I was going to go through Nebraska quickly. These are the TEDs that were identified in Nebraska. And again, the biggest ones were planting date. Kind of interestingly, in Nebraska, we see that the higher seeding rates are generally found in the higher yield environments. And that's one of the things that was interesting in Nebraska that didn't hold true for other states. Tillage was another point that popped out, as well as the use of foliar fungicides and or insecticides. In Ohio, we actually, Dr. Laura Lindsay did an excellent job of getting a lot of data out of Ohio. So we have pretty much almost the entire state painted. Again, we can break these down by TEDs, planting date, seeding rate, row spacing was relevant in a couple different TEDs, artificial drainage, tillage, and foliar fungicide and insecticide. Okay. Iowa, here I'd like to thank the Iowa Soybean Association on their on-farm network. Again, they did an excellent job of getting us data, as you can see, by how much of the state is painted, and how many red dots are across the state of Iowa. We can kind of dig into this a little bit. Again, I don't want to sound like a broken record, but it's planting date, seeding rate, row spacing to some extent, tillage differences based on whichever TED you're in, as well as plus or minus foliar fungicides and insecticides. So again, some similar things popped within these different TEDs across these state borders. So I know I went through that very quickly, but I wanted to make sure I had time at the end for some questions and to talk about the next project. So our next project we got going on, the North Central Soybean Research Program is funded. It's called Boots on the Ground. And really what we're doing is we're going through and field validating all of the information that we learned from the survey analysis and TED information. We're going back into farm fields, large-scale farm fields, and working with individual states and individual organizations and testing these interaction suites to really make sure that our methodology wasn't a function of our statistical analysis and would physically hold true in the field. So stay tuned for that. Again, as you would expect, this was a difficult year to do this project, mainly because we see planting date was a big driver in a lot of TEDs. And frankly, given the prevent plant acres and spring we've had, this has been a big challenge. But we were able to get at least some of the plant experiments in, but stay tuned. We'll be talking about that this winter and have updated information on my website, which is again, www.coolbean.info. Just to let you kind of get an idea of the depth of these on-farms. So we picked specific TEDs based on acres, okay? So again, if you look here in Minnesota, the Minnesota TEDs that obviously would fall into parts of northern Iowa as well, not just Minnesota, covers roughly 2.3 million acres. So roughly through the TEDs that we're identified and are validating our statistical processes in the field, counts for roughly 25% of the U.S. North Central soybean region. So again, it's pretty exciting for us to be able to take this information, this grower-supported, NCSRP-supported research, go through this process, have such great relationships, and work with our farmer board members, and then take this back into the field, because this really helps streamline our research focuses moving forward. So again, stay tuned for these updates as we are able to develop these and push this information out. With that, again, I want to thank the North Central Soybean Research Program for providing a significant amount of funding for this project, as well as Nebraska Soybean Board, Wisconsin Soybean Marketing Board. I know other state QSSBs, Ohio, others put in additional dollars. I just want to thank the farmer boards and across these states for supporting us. For information on this, please go to my website, which is www.coolbean.info, and follow me on Twitter at BadgerBean. So with that, I'm going to step back and ask Chris if there's any questions in our last 10 minutes here. And again,
Yeah. Great, Shawn. Thank you. Wow, that was a great presentation. Fascinating study. Lots of great data and lots of great conclusions. That sounds like are going to be coming out here for quite some time. So we do have questions, plenty of them. To the audience members out there, you never know how quick we're going to get through these questions, so please feel free to keep submitting them, and I'll pose them to Shawn, and we'll see how many we can get through. We'll go a little long if we have to. So, all right, let's get started. Some of these are pretty specific, Shawn, and I'll try to point to specific parts of your presentation where they probably are referencing, and I'll do my best. So the first one I want to bring up, and some of these I'm going to save for a little later. So the first one I want to use, though, is this individual asks, have you used biplot statistical analysis to relate variety to yield under given field conditions during the crop year? Talking a little bit about the variety aspect.
Yeah, that's a very good question in terms of the variety aspect of that. And frankly, that's one of the 80 research papers we have yet to look at and write. So I'm really shopping this data around. I shouldn't say shopping it around, because that's not the best term to say about that. But we're looking at university colleagues and collaborators to go in and help us with this, because as you can tell, it's an immense amount of data. Some of the things we were able to do is we were able to not look at specific varieties, but we looked at maturity groups. But we would be able to go in and look at specific varieties too. We just hasn't, that one hasn't risen to the top yet of what we're looking at. But good question.
Yeah. What's your gut tell you about variety? Big impact, less impact? I mean,
well, I mean, it's a huge deal for us. I mean, variety selection is the number one thing. I always quip that, if you don't spend time in looking at genetics and pairing it with the specific TEDs, and I know companies do, and I'm not going to name names here, but every company tries to pair it on specific soils or environments, and they have different names for doing it. But I mean, if you get that wrong, and if you plant a dog, you're going to harvest puppies. So, I mean, genetics are the number one driver.
Yep. Great. Thanks for commenting on that. All right, the next question. It came about mid-presentation. You had a slide up where I think you were relating yield to percent stand, I think. Mm-hmm. At that time, this person posted this question. What was the average yield in each range of seeding rates? So, I don't know exactly which one.
Yeah, I know exactly which one. I'm not going to have the specific yield memorized because that's still the paper under review. But what we were looking at is we basically put these into terciles. So in the high yield environment, we would have been above 70 bushels per acre. We averaged 75, if I remember correctly. The medium yield zone would have been somewhere between 45 and that 70, and the low yield environment would have been under 45. So we were trying to parse it out by yield environment and based on those clusters, because we were kind of looking at it at a different scale than its TEDs, but doing kind of a cluster environment. So stay tuned for more of that to come out. That's still in process.
Okay. Well, I got this next question from multiple people. Maybe you could take a few minutes talking about it. And that is this. One person asked specifically, does fertilization matter? Another person asked, where does soil fertility fit into high yields? I see it's absent from the discussion. Wonder how it fits in. So maybe you want to take a little bit of time talking about fertility.
Yeah, that was a hard one to parse out, frankly. We, because we don't have specific gridded soil samples. I mean, we could go into it and do a post hoc analysis because we can identify the farmers. If they have gridded soil samples, we could easily go in and do that. However, that's one of the boxes that the farmers, filled out maybe a little vaguely. And we have to remember in soybean, it's really hard for us because these are as applied rates, and we don't know what the specific soil tests were. Were they high, whether they high tests and they were still putting it on, or these low yielding fields? And again, we could maybe go through and do some assumptions on that, but I think we don't have enough ground truthing to dig into the soil fertility aspect.
Mm-hmm.
Again, I know it's critical and it's important, and I think there's some more digging we could do in that one, but just kind of the shotgun approach, I don't think we had enough base information on the soil fertility side. That's a great question, and that's one that we're still trying to figure out ourselves as the core team of how do we address that.
Good, great. Okay, you talked about yield gaps. We have some interested folks asking about, looking to the future. How do we close these yield gaps? We've talked about agronomy. We talked a little bit about genetics. What do you think the contribution of each will be going forward? We can talk with the genetic side. You might talk about the breeding efforts, but also the traits. And of course, agronomy across the gamut. There's always this discussion between agronomists and breeders about who's going to be, better at closing yield gaps or who's contributed more to yield gain in the past. What are your thoughts going forward and your gut reaction to that type of discussion?
So I have a lot of breeder jokes I can tell right now, but
Oh, great.
I shouldn't. But what we basically found, and Jim Specht did a really good job of this. He was kind of a physiologist, so he dabbled in both sides of the breeding and agronomics. And over the last 20, 30 years, he would argue, and I would agree, that it's roughly a 50-50. Both breeders and agronomists have both contributed about 50% to this yield march that we've had on soybeans. Mm-hmm. Obviously, genetic yield potential is always important. However, if we looked at some of these things, just the application of seed treatments, planting earlier, having better precision equipment, planting, better weed control strategies. There's a lot of things that are interplay in the agronomy side. So from where we look at things, we're looking at that 50-50, historically where we're at. Going forward, I think we'll probably be about that side. Obviously, as some of these new traits come in the marketplace, and I noticed that they're hopefully with our president had made a discussion and a point of emphasis, I believe it when he was in Iowa yesterday or the day before, about trying to speed up how these new traits make it in the marketplace because they're very costly. They're very challenging to get those in the marketplace. I think that will help us. And many of those traits, again, will be likely on the pest management side of things, either some type of GM for SCN, because we see P8788 is failing us. We're losing ground there. The weed management side, even with the new traits coming in the marketplace, we have some strategies there, but we're one or two more genetic mutations on water hemp to having, water hemp is resistant to basically everything out there. So there's some really challenges ahead of us. So to that point, I think it's 50-50, and we're going to continue to make gains on this. I know my postdoc wrote a paper, it's published on my website, is talking about how with the changes in our environment, what the optimal planting date is. And there's some states that are still 2 weeks, planting 2 weeks later than they should, and that's free yield. What I mean by 2 weeks later than they should, the average plant date, according to NASS, and we can debate how accurate that is, they should be planting 2 weeks earlier, and that's free yield. If you in some of these environments, 2 weeks, that's 14 days. You're roughly anywhere from 5, 6, 7 bushels free yield. And there's some places we can make some changes that won't cost farmers a lot of money.
Oh, nice. Oh, good to know. Good information. I'm going to round this discussion out with just two questions, and it brings it back to the sustainability piece, since these topics right now are kind of hot in that landscape. And then we'll wrap up the Q&A. The second to last question, any comments on cover crops? Did you do any documentation on cover crops and any contribution? Super hot topic, right?
Yes,
So people want to know.
It's a super hot topic. So we did collect a little bit of information on that. I mean, if a farmer did use cover crops, they noted it in their survey. We just didn't have a high enough N.
Sure.
We just started this back. Basically, the data was collected from 14, 15, 16, and 17. And the cover crops really started kicking off in 17. So it was kind of the back end of this where we really saw a lot of cover crop acres. With that being said, however, the North Central Soybean Research Board is funding a big project right now looking at cover crop adoption in the North Central region. So we're looking at termination timings, looking at specifically, this is kind of more of an entomological bent to it, but looking at both beneficial as well as detrimental insects in these environments. So please be aware that this is going on right now in this time and space, but we just didn't have a high enough N from the reported data that we had to make any comments on cover crops, because again, they're going to fit into these TEDs. I mean, there's going to be some TEDs where they work great, and there are going to be some TEDs that, you know what, they might not be your best choice. So,
Right. Yeah. Well, in the future, hopefully get more data on that. Last one. Did you have enough information in your data collection and analysis to figure out some recommendations for organic growers?
So we did not have, again, a high enough N for the organic growers. This information was sent to basically any farmer that grew soybeans, at least in our state. Our checkout board mailed it to every farmer that grew over, I think, 40 acres of soybeans. So again, I think some of the recommendations for organics are obviously going to differ based on inputs and to make them certified. So that would be a question, and actually an interesting webinar for those that have done some work in the organic space. And I know here at University of Wisconsin-Madison, we do work quite a bit on the organic side, so we do have some recommendations, at least for our state growers, on that side of things.
Yep, absolutely. Yeah, we are doing a bit of a webinar series on that, and soon a podcast series on organics, so we may touch on that a little bit. It's an interesting topic. That's all the time we have for the Q&A, but before you leave today, I just want to point out something that might be of interest to you, and I want to share this with you before we say goodbye to Shawn too, and that is the USB Tech Toolshed. So USB recently, I'll still say recently, even though it was a little earlier this year, launched the Tech Toolshed in response to all the technology you see out on the farm right now. That farmers experience, that certified crop advisors experience, that anyone working on the farm is experiencing. This was launched to help folks sort through and navigate the technology landscape. So I encourage you to check out the Tech Toolshed. You can see the web address on your screen right now, unitedsoybeanboard.org/Tech Toolshed, or follow it, that is the Tech Toolshed, on Twitter at Tech Toolshed. So check it out. Maybe it'll be helpful for you. I bet it will be. And with that, Shawn, I want to thank you for being here today. It was a great presentation, lots of information. I encourage our listeners to please go back to the recording, which we'll provide. We will also provide a copy of the slides so that you can dig into some of this data. Of course, you can also go to Shawn's webpage. You'll get the names of the collaborators for the presentation. I'm sure they're all digging into this data more, with many great results to come in the future. So Shawn, thanks for your time. We thank United Soybean Board for sponsorship. And as attendees, we thank you for coming today. Be on the lookout for the final piece, the final webinar in this trio, and for future webinars coming from American Society of Agronomy. With that, thank you, everyone. Take care. Hope planting is working out for you as best as can be expected, and you suffer through this period and come out on the other side, hopefully stronger. So thank everyone for attending today. Take care. Have a great day and a great week. Bye-bye.